All right. Good evening, Jamie.
Evening, sir.
All right. How are you doing?
Good.
All right. Good to hear. Very good to hear. All right. Now, I made sure to go through and check all the computations, and they're all up to speed. All right. Very good. All the computations are up to speed. But I just had one issue, and that was with regards to the box plot. Now, what's the issue? I would love if you could ensure that the scale is a little more narrow. So for example, notice that we have from right here, there's no ratio of 0.94 or 0.96. So maybe if we could start it from 0.98 and end it up to the 1.14. You get what I'm saying?
Yes, sir.
Yeah, because you want it to maximize the scale, all right?
The problem was I have Excel 13 and Word 13, so I don't have the
Oh, you don't have the
box
updated
and
Excel.
whisker thing yet.
Okay, all right, all right. I have the latest PowerPoint, but all right, what I'm gonna do is I'm gonna send you a link that you can update your Microsoft, all right? So it might take some time for you to download and update, but I have the latest one that you can. Your computer have enough space because I think it's 4
Yeah, it does.
gigabytes. It's gonna be 4 gigabytes to update.
Yeah, I have the space.
All right, very good. All right, so once I do that, then everything is perfect. So far, everything looks really good. All right, so far we're good. Nice. And yeah, man, I'm telling you, table complete, very good. All right, of course, when we're doing our final brushing up, like stuff like this, which is minor, I always like when you start the page. So let's say you work out the measures of central tendency here. Then you can put on the next page the measure of spread, just for it to have continuity, and also for them to mark and say, it's presentable, organized, and all of that stuff. It's not patchy. So we put the measures of spread on a different page. But for now, it's good as it is. All right.
All right.
All right. So very good, because all the computations are correct. So that's the main part that we're focusing on, which is good. So now that we get that out of the way, all right, today the part of statistics that we're going to be dealing with is the rest of the notes in this chapter. All right, we want to finish statistics in the next, I'd say by the end of February, we should finish statistics and then pretty much finish calculations for our SBA. So today, what we want to cover is the easier parts of statistics. All right, we want to cover bar chart, pie chart, histogram, cumulative frequency, all of those stuff we want to cover, the different ways we can present data. All right, tally charts, frequency tables, cumulative frequency, bar chart, pie chart, line graph, histogram, cumulative frequency, all of that we're going to do today, except the scatter plot. We're going to do the scatter plot lastly when we're looking at linear regression, all right? Because I like to combine the two. Is that okay?
Yes, sir.
All right, so today you're going to be doing a lot. So let me allow you to be the host. You're going to be doing a lot of doing today. All right, but in the meantime, just to review, what is frequency tally or frequency distribution? So frequency distribution is pretty much a group of similar frequencies in a table. That's all is frequency distribution, right?
Yes, sir.
So you plan to go to the University of the West Indies?
I don't, it's not planned, but I might go
Oh,
there.
you want to go overseas, but if anything, then you'd go
Yeah.
to university. All right, very good. All right, because I know medicine is very expensive in every part of the world. So that's why I presume maybe you wanted to stay locally. But as long as you can get full scholarship, and trust me, Jamie, with your grades, you're definitely going to get full scholarship as long as you're also active at school. Are you in extracurriculum activities?
Not a lot. I try to do basketball, but kind of interferes with school sometimes.
All right, no problem. It don't have to be sports, and it can be clubs as well. Make sure you're president of this club and something else, just to have it on your portfolio. Trust me, it goes a long way, especially when you're gonna do the scholarship interview, right? And you can link the two together, just to tell them that, you know, this is what I do. I'm the president of this club, tourism club, sixth form association. You know, and then you can state your accolades, tell them how many ones you got, tell them you got, you know, distinction in this, and it's beautiful. Tell them also you're in the merit listing, not only in Jamaica, but in the Caribbean. Those are some really nice accolades you have. So as long as you do some extracurriculum activity, it's gonna improve your chances of getting the best quality scholarship you can get. All right. Yeah, so definitely get into 2 or 3 extracurriculum and try to be the president or vice president or something for next year. So, as we said, with ungroup data now, ungroup and group data, pretty much all we're going to do is, if they give us something like this is just a table showing students' score on simple linear regression. They did a simple linear regression test at University of the West Indies. All right, so University of the West Indies, 18 students did a test on simple linear regression. These are the scores out of 20. Forgot to include that. Out of 20. So somebody gets 16 out of 20, 9 out of 20, 10 out of 20, 9 out of 20, 4 out of 20, 3 out of 20, 11 out of 20, and so forth. So of course, all we do then is, this is the distribution of it. Notice that one person got a 0, one person got a 3, 2 persons got a 5, 1 person got a 6, 4 persons got a 9. All right, and so forth. So that's all is the frequency distribution table, or the tally chart. So another way they like to call it is frequency distribution or tally chart, right? That's easy stuff. We won't ask you to do any question on that just yet, all right? So no problem. That's the frequency distribution. Now, with group data now, of course, it's going to be in a particular interval, all right? So maybe they group up from how many persons get between 27 to 31, between 32 to 36, 37 to 46, 47 to 51, etc. All right?
Sure.
Yes.
I don't think you sent this document.
I didn't send this document.
I don't think so.
All right, let me send this one. All right.
Wait, no, I have it.
Oh, you have it. Okay, great. Because I was like, whoa. Okay, yeah, because from the started statistics, I should have sent this one. All right. I probably should have renamed it statistics notes, because I named it integrated math, right? So maybe that one is, yeah, I should have renamed it. You can rename it, of course. All right. So sometimes they can give you a number of stuff in a particular interval, and then we also need to just group it to put it in our frequency tally. But that's nothing major so far. All right. By the way, Jamie, did I look at skewness? Because for some reason, I just don't think I did skewness. But did I? Did I tell you the formula for skewness?
No.
All right. So I realized I left out something then. So for everything that we did last week, there's a formula that we need to talk about when a data set is, all right, I know what I'll do. I'll include it next week. But you can write down the formula for now. It is skewness. All right. Skewness. What is skewness? This is determine whether a data set is biased to the left or to the right. What do I mean by bias? So, for example, Jamie, a data set that we call to be symmetric is, look at this. Let's say I said somebody got 5 out of 10 in a math test. Somebody then gets 7. Somebody got 9. Somebody gets 7. Then somebody get 5. These are the 5 grades. We'd say that this data set is symmetric, right? this data set would be said to be symmetric. All right. But notice that right here, if you were to find the mean score would be 5 and 7, 12, 21, 28, 3, 33, 33 out of 50. The mean score is roughly 6 point something, 6.6. Now I can give you another data set where the mean is 6.6, but it doesn't look nothing like this. Maybe somebody got 1 out of 10. Maybe somebody is going to get now 10 out of 10. Somebody else will get 9 out of 10. Somebody will also get 4 out of 10. That is 11, 20, 24, and somebody get 9 out of 10. Notice that in this group, it's all over the place, right?
Yes, sir.
So this one, right here, all over the place, we'd say that this data set is skewed. This data set is skewed, right? When a data set is skewed, it's not necessarily balanced on both sides, right? So you always hear them talk about balance in life. And it's the same thing with schools. We like to see if there's a balanced number of person that is getting less than the mean and more than the mean. In that case, we say that the data set is balanced, all right? But if it's something like this now where you have whole heap more persons getting closer to maximum grade and probably just 2 persons that do extremely poor, those 2 persons that do extremely poor, we call them outliers. And so we say really and truly this is a good class, but you just have 2 bad students. In that case, we call the data set to set. We say that the data set is skewed. Now, there's just a simple formula to measure skewness, Jamie. It is mean minus mode. Now, Jamie, whenever mean minus mode is greater than 0, we say that the data is positively skewed. Whenever it is greater than 0, we say it is positively skewed. Whenever the data set is such that mean minus mode is equal to 0, then we say that the data set is symmetric. And whenever the data set is such that the mean minus mode is less than 0, we say that the data is negatively skewed. All right, negatively skewed. So you can use these formula now to go back and check to see if all the questions we've done so far, like the Hetmeyer question, the question with Brian and Lewis with their grades, you can go back and look and see whether the data was positively skewed or negatively skewed. That's something that's very popular on the exam. So I'm going to include it in the notes for next week, because next week we're starting distributions. So what I'll do is put this right at the top. All right, so my apologies for not putting this in there. I'm going to put it right at the top of the distribution notes for next week, all right?
All right.
All right, so next week is a lot of fun, but just you can take down this for now. That's the formula for skewness, all right? And then we'll get back to it next week, all right? We'll look more into it next week. Skewness, I just want you to have an idea though of what skewness is. We're just generally trying to look at the shape of the distribution, all right? You can generally see the shape with the box plot. You can see the shape with histogram and all of those stuff. You'll be able to see where majority of the data lie, but that's now just a formula that you can just easily use to verify if the data set is either symmetric or if majority of the data is to the left or to the right of the mean. All right, so as I said, these are just frequency tally. I'm not going to ask you to do any frequency tally question. All right. What I want to jump to next is how we use frequency tally now to help us to find what we call class intervals. Jamie, what is class intervals, if you remember from CSEC?
It was.
Do you remember?
I think it's. Yeah, I can't remember.
All right, no problem. So you see these values that are given right here, these would be the class intervals. All right, so for your independent variable, right, these are your class intervals. All right, that's all is class intervals. So the intervals such as 20 to 29, 30 to 39, 40 to 49, these are all class intervals. All right, now the number, the lesser number in each interval is known as the lower limit, and the bigger number is known as the upper limit. So they call it the lower class limit and the upper class limit. All right, so those are your class limits. Now, the next thing to note about it is that you have what is known as the upper class boundary and the lower class boundary. So sometimes in a data set for group data, it might be a continuous data set. So numbers from like 19.5 go up to 29.5 would be included in this category. From 20 to 29, we include 19.5 going up to 29.5. We then say that the 19.5 is the lower class boundary of 20. You just take off 0.5 off it. And then we'd say that 29.5 is the upper class boundary for that group right there. Then what we then say is that the class size or the class size for all the intervals, the class size, it's equal to the upper class boundary minus the lower class boundary. That's how we find the class size, or some people might call it the class width. All right, so here it is. So the numbers 39.5 and 49.5 are the class boundaries for the interval 40 to 49. The smaller number 39.5, we call that the lower class boundary, and then 49.5 is the upper class boundary. The difference between the two, we call it the class width or the class size. And then the last thing to remember, Jamie, is how we find the midpoint. How we find the midpoint of a class, of an interval. So to find the midpoint, Jamie, right, what you do is add the upper class limit and the lower class limit and divide by 2. Or some persons might say add the upper class boundary and the lower class boundary and divide by 2. They tend to give you the same value. All right? And that's how you find the class midpoint. All right?
Yes, sir.
All right. So now all of this data right there is extremely important because we're going to utilize this now in order to be able to draw histograms. All right. We're going to utilize it to draw histograms. And we're going to utilize it to, we're going to use it to do histograms. We might use it for maybe a bar chart, depending on what a question wants. Because they're not going to just, even though we look at frequency tally, they're not going to give you a question where you just fill out a frequency tally. So let me show you an example. All right. So for example, they might give you a table like this, right? The frequency tally, that is just the first part of the question. Look how much data between 17 to 19. You just look through. You maybe see 19 here, 18 here, 18 here. You keep on looking and maybe it's 4 and you put 4, right? But what I'm saying though is they're not going to just give you a frequency tally question to do by itself. Usually something else follow. We're going to be plotting something, either do a bar graph or something, right? So that's why I'm saying it wouldn't make sense to just give you a frequency tally to do by itself. So that's the point I wanted to bring across. So now, with that being said, we're going to look at how we construct a histogram. And then the first set of questions I'll ask you is regarding to a histogram. So this right here, Jamie, it says, look at this as an example. It says the amount of money collected from 300 persons involved in a sponsored walk is tabulated below. And then we're going to draw a histogram to represent the data. So it says the amount of money in thousands from $1 to $2,000, 20, $3 to $4,000, 93, $5 to $10,000, 90, and so forth. So to draw the histogram, Jamie, the first thing you're supposed to do is histogram. Always remember histogram. All right, I like when you create a column and you just want to create a column with the lower class boundary and the upper class boundary. All right, so the lower class boundary of 1 would be what?
Would be 0.5.
Very good, 0.5. And the upper class boundary is?
2.5.
2.5, very good. Lower class boundary for 3?
Would be 2.5.
Very good, 2.5. Then this is?
4.5.
Very good. So histogram is similar to bar chart. The only difference is that histogram utilize lower class boundary and upper class boundary. That's the only difference. So in this case now, all you do is on the x-axis, you're putting on the amount here. And remember, you're using the interval as the lower class boundary to the upper class boundary. So let's say the lower class, 0.5 to 2.5. Then the frequency is 20. From 2.5 to 4.5, that frequency is 93, somewhere up here, so 93. Then from 4.5 to, I think, 10.5, then that frequency is 90. Come up where to here, maybe here's 90. I know it's just a rough sketch, all right? And it continue. So that would be the histogram here. All right. Why did I put this from negative? What? 1, 0.5. Okay. All right. This should have been 0.5. My apologies. Oh no, this is a different one. Oh, I didn't put in for that one. Oh, why did I leave out this one? All right. So the histogram for this one should have been right here. All right. So I do use an app to create these, and I'm going to show you the app today. Is it called a Geometer Sketchpad? An app I used to actually make this, but this one should have been right there, but you can complete it for me, right, Jamie?
This one.
So this should have been right here in the notes. All right. So this is just an example of another one here. And the examination marks, I was just giving an example here with the frequency. Look, it's relatively a bar chart. The only difference is that you start it from the lower class boundary to the upper class boundary. And that's it. So to construct a histogram, you just start from lower class boundary to the upper class boundary. And that's it. Then you just plot the frequency on the y-axis. That's literally it. Literally, that's it for histogram. All right. So with that being said, I have in this worksheet here, as you can see, 15 pages. I have 3 histogram questions. All right. I want you to go ahead and do the histogram question. So let me look for a histogram question. 3 of them in there are histogram, so don't worry. Frequency polygon, cumulative frequency. Where's my histogram? All right, here's a histogram. All right, so I know you're not doing it accurately with a graph, but no problem. So this is page 12 of it. So I'm gonna allow you access now. What I want you to do, Jamie, is you can actually write on the screen. So you can open the document with Microsoft Edge and you'll write on Microsoft Edge. Just to write exactly on the screen, and maybe you can sketch the graph on the Zoom whiteboard. All right? All right. Yes, this question. Yes. So this is your question to do. These are actually CSEC questions, but they do take questions from CSEC straight from the Intimates in statistics. All right, when it relates to histogram. So no problem. So this says a class of 26. All right, so that's the question. Copy and complete the table. So the first part is frequency tally.
How do I?
All right, so I don't see the writing option. Cancel. Oh, are you still using 2013 Microsoft Edge as well? Oh, okay. Yeah, okay. You're able to write there. You can increase the size. All right, good. It's okay. Very good. That is correct. Very good. Well done. All right, that will give you 2 marks. So the next part now is to draw a histogram. Notice they give you how they want you to use. Use a scale 2 centimeter to represent 5 on the X. So in an exam, of course, you ensure that you use a proper scale, right?
Yes, sir.
All right, but I won't have any issue because you can just do that now on the white screen and no issue if, well, you're not necessarily using a scale. I just want to see the rough sketch to see that we're good. Yeah, I was saying that you can draw it on the white screen. So maybe just come back to the numbers here, but draw it in the Zoom white screen. Yeah. Very good. Lower class boundary sharp. All right, very good, Jamie, very good. But only thing now is I always say put on your axes. You need to know what's on the y-axis and what is on the x-axis. And then you write your scale. Very good. Distance in kilometers. All right, very good, very good, very good. Now go back to the next part of the question and see what else they ask after you get the histogram. By the way, Jamie, looking at this histogram, right? Tell me how do you think, is this data um skewed to the left, skewed to the right, or is it symmetric?
I think it's
Where do you see majority of the big bars?
skewed to the left.
More skewed to the left. Look at it. Most of those it's skewed to the left, right? Yeah, so in that case, we're saying that this data set would be what we call negatively skewed. When it's skewed to the left, it's negatively skewed. So even though you don't, even though we don't ask, even though they don't ask for skewness, I want you to go back to the table, work out the mean, look at what the mode is, and then you're going to work out the skewness, and I guarantee you're going to get a negative value. So use the skewness formula. To check it. I don't know if you're writing, I'm not seeing it anymore. It's kind of got a little narrow. Yes, skewness, mean minus mode, good. So yeah, work that out for me now.
Sir, honestly, I don't remember how to
Find the
get mean
mean.
from my table.
All right, go back to the table again. All right, so remember, how to find the mean is first we'd say you need to find the midpoint for the data set, and then you multiply the midpoint times the frequency. So you'd create a column on the left side of it for the midpoint, and on the right side, you create a column for f times x. We'll call in the midpoint x. Yeah, so write down the midpoint there. All right, so I'm glad we're doing this. So at least we're integrating the different sections all together. So you still get to refresh doing mean. So even though we're not doing mean and standard deviation, still want you to be doing questions with them, right?
Yes, sir.
All right. All right, you need to pick up, there's a pattern. Each group is just increasing by 5. You don't need to work out anymore. I got the first one and the second one. You already know the rest of them. $36, $40, $33 plus 5, $38. Right, Jamie, you wrote 36. The midpoint should be 38. Yeah. All right, good. Then remember, you add up all of those now because the mean is the sum of f of x divided by n. And in this case, it's all the numbers that they'd have given. So they told us, I think it was 26 numbers at the top. All right, what was the mode? You can't use the table. You have to look at the top to see the mode. Which one occurred most frequent?
21 to 25.
All right, 21 to 25, but look specifically at which number repeated most.
It's the 22.
22. Notice the mean minus mode gonna be what number? Gonna give you a negative value, right?
Yes, sir.
Very good. So in that case, we say that it's negatively skewed. And we gathered that it's negatively skewed because we see that majority were what?
Or on the left side.
Left side. When majority of the big boxes on the left side, we definitely can say, oh, this data is definitely negatively skewed. So all you do is put that because this is less than 0. When you work out skewness, you then just put less than 0, that negative 1.7, you put less than 0. Then you tell them, hence it is negatively skewed. Yeah. Now, Jamie, not all the time a data set is going to have a mode. You're going to find data set that don't have a mode at all. That's when you use a different formula for skewness. So that one is 3 in bracket mean minus median. All right. But of course, I'm going to put everything well typed together next week. So the next formula, if you want to write it down from now, is that skewness is 3 in bracket mean minus median. That's for a data set that doesn't have any mode. All right. You wrote it down in your notebook?
Yes, sir.
All right, great. All right, so go back to the question now and see what else they ask after that. So they say calculate the probability that a student chosen at random from the class recorded the distance to be 26 or more. We get 6 out of 26.
The 3, 2, and 1 from the
Very
table.
good. That's correct. Yeah, I'm just testing to see if you're confident. Very good. All right, sharp. Now look at this now, Jamie. This is where skewness come in place. So read what part D say and tell me which one is the answer.
Part D.
Yeah, part D. It says the PTA plans to set up something. So literally they're asking you which is the most accurate central tendency to use in this case. Which one would you say?
It's a median.
Very good, Jamie. Very good. The median. Tell me why the median.
Well, because it's where uh it's where most of the students will be traveling from.
All right. All right. No, you see that now? That's not necessarily how I want you to explain it. How I want you to explain it is that because the data set is skewed, it is skewed in the, remember we said it was negatively skewed?
Yes, sir.
Because it is skewed, and therefore the mean is not a very accurate measurement, or the mode is not an accurate measurement of the central value. So the closest value to be in the central value of all the figures would be the median. That's because it is not symmetric. So all you have to tell them is because it is not symmetric, then the median is best. All right?
Yes, sir.
All right, nice. So you realize how skewness come in play right there. So very, very, very good, Jamie. That is how you do a histogram. Now, don't do any more of those questions now. Histograms and bar charts are very similar. So you would have remembered bar charts. I want you to open the document that says not drawing bar chart, bar charts, tally charts. I want you to open that document.
Yeah,
Yeah, let's just start with an easy one. Let's start with number one. So fill out those table right there. Put the tally and the frequency. How do you put tally?
using sticks.
Yeah, very good. The sticks or the strokes. Good. That's green that you shade. Why you put white on the green?
Let's see.
All right, good. So now give a bar chart for that diagram there. So notice with the bar chart on the x-axis doesn't necessarily have to be numbers, and there's also spacing in between each different groups, right?
So
So bar chart is definitely not continuous data, and it is more used when we want to compare. Maybe you want to compare progression between two objects. We don't know, two things, right? It is comparing. We use bar chart generally to compare as a whole, or compare maybe progression over years. Maybe comparing January 2020 results of CSEC in comparison to January 2022 CSEC results. So you can have two bar charts side by side and look at the number of ones, twos, threes, fours, five, look at the frequency and compare. So that's why we use bar charts for comparison. In this case, they're comparing as a whole. All right. All right, so go down to the next one now. That's just the warm up. All right, not doing the same thing straight away. Go down. Not that one. Not that one. Oh, yes, look, that one have what I wanted. Write down the range just to refresh your memory. So complete the tally and the frequency and write down the range just to refresh your memory of range. Very good. A lot of person would put the mode is 7. So I'm happy that you wrote 9. Good. The range. Very good. Highest minus lowest. Good. All right, moved on, moved on. Just wanted to check that you remember. You don't need to put the bar chart. You go down, not that one. This one. This one right here, interpreting bar chart. Sometimes they ask you to interpret. So I want to see if you interpret it well. It says,
which club?
all right, so it says Newport United Football Club. They play in the same league, right? They win how much in games, they draw how much in games, and they lose how much in game. They give you the points down there. They said for the club, they finish with, wait, which club finished the season with more points? All right, no, the wording is incorrect. All right. So let me rephrase this right here. Let me rewrite it. So, all right, I want you to state how many points did they finish with. I want you to then tell me also how many points did they drop in terms of losing. And then tell me their goal points difference. All right, very good. They finished with 46 in total. How many points did they drop? All right, so they dropped 51 points from drawing and losing. Very good. All right, very good. The seven, well, why would you multiply it by 3? You sure? When you draw a game, they don't drop 3 points. They get 1 out of the 3 already, you know.
Yeah, see what I'm saying.
$44, yeah. Good. Because out of 30 games, they should have maxed the can get as much as 90, but they only made 46. So of course it's 44 they dropped. 90 minus 46. That's another way. All right, very good. All right, very good, Jamie. So we have good idea of what is going on in terms of bar chart. There's no more questions I want you to do. No, there's another one that I'm not gonna draw. So I want you to go to the question that's the paper that says reading pie charts. Because we don't need to waste time on that, right? That's waste of time. So go to the one that says pie chart. All right, so pie chart is everything out of a whole. So I want you to interpret some of these pie charts for me. So it said the pie chart shows the colors of 32 beads. How many green beads are there? Answer the first one. Very good. A quarter of 32, because that's 90 degrees out of 360 for a circle. Very good. So 8. All right, second one, go ahead. Most common color. Very good. The black. All right, red. Good, good. 45 degrees. All right. Here's another one. Very good. So it says there are now 24. How many have blonde hair? Very good. All right, easy so far, no problem. All right, good. What fraction is red? All right, they say there are 24 counters in the bag. Work out how many black are there. All right, very good. You fully remember pie chart now. That's a calculation I wanted to see. And you know how to construct pie chart if they give you the information, right?
So
All right, very good. So, all right, wait, go down. Let me see one that's gonna complete the table. Let me see. But that's easy as well. All right, yeah, do that one for me then. Ninety out of 360 can't equal 12. 90 out of 360 times the total equal 12. So maybe you want to call the total x. And then you find what the total is. So 12 divided by a quarter. Very good, Jamie. All right, very good. All right, so we're going to move along now. No need to look at the rest. So we continue now from pie chart. So thank you, Jamie. So we'll complete pie chart, we'll complete bar graph, and we'll complete histogram. So those are out the way. I will look at frequency tally. So the next one that is popular that they love to ask is cumulative frequency. All right, so let's move on away. Now, cumulative frequency, Jamie, literally, cumulative frequency, all we're doing is we're gonna plot on the y-axis the cumulative frequency at the various points. So we plot the upper class boundary on the x-axis and the cumulative frequency on the y-axis. For example, this is a data set right here. Upper class boundary would be 10.5, 20.5, 30.5, 40.5. But if you remember from CSEC, what you do is create a column, an additional column known as the cumulative frequency column. As the word cumulative mean, adding together, accumulate over time. You make $5 this year, next year make $20. For the 2 years, you accumulated the sum. So cumulative frequency starting from 3. Then when you get 8, you accumulate 8 more plus the 3, 11. Accumulate 12 more, that's 23. Accumulate 14 more, 37. Accumulate 10 more, 47, and so forth. Right, Jamie?
Yes, sir.
All right. Once you get the cumulative frequency, you then go ahead and you draw a graph with the cumulative frequency and the date and the upper class boundary. All right. So in this case right here, let me open up the graph. I'm going to quickly run through it. So this is just showing how persons did on a test right here. I'm just making up something, maybe marks. Only 2 persons get between 71 to 80 on whatever test I would have given. You have 3 persons getting right here. It's not bad really. It's really not bad because this look very distributed because the mean more than the median would be somewhere in here. So looking at the numbers, it's very difficult to tell if it is positively skewed or negatively skewed because look at this. 8 and 12 and 3 is 23. 23 person get less than 30 out of 80. But looking over here, 10, 6, 5, and 2 is also 23. You see that, Jamie?
Yes, sir.
They have 23 persons to the right and 23 persons to the left. So we can't really tell if it's symmetric yet. In a case like this, it's best when we just use the formula. Because just looking at the numbers, plotting a bar graph or whatever, won't tell you. So you see why the formula is important, Jamie? Because you might say, sir, look how you could have looked and know that the first one was negatively skewed. But then there are going to be cases where the numbers won't just tell you if it's negatively or positively skewed. That's when you need to use the formula to calculate and determine, right?
Yes, sir.
So that's the beauty of the formula. In all cases, you'll know whether it's positively or negatively skewed, right? Using statistical diagrams like Boxplot, histogram, those only helpful when it's a big outlier, when it's obvious. But when it's not so obvious like this, you won't necessarily know. So let's go ahead and plot this now. So we're going to plot our upper class. Let me share screen here. So we're going to plot our upper class boundary. All right, let me go on grid form. All right. So of course, you want to make it relatively accurate. So of course, you'd use a scale. Looking at this right here, we notice that the upper class boundary going to be 10.5, 20.5, all the way up to 80.5. All right, so we want 10.5, so maybe I use 10, 20. I let in 2 centimeters represent 10 units, 40, 50, 60, 70, 80. All right, and I want 10.5 is just slightly outside of it. All right, so just to tell them the scale in this case is we're saying that the X 2 centimeters represent 10 units, but we're not going to write the word units. It's going to be 10 marks. All right, so 10 marks. And then on the y-axis now, the y-axis went up to the frequency is the most it's going to go up to 60 cumulatively. So 60, how can we distribute 60? Looking at this right here, maybe 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, yeah. Each represent 5, so 10, 20, 30, 40, 50, 60. So it's the same scale on the X and the Y. So 2 centimeters represent now the amount of students, all right? 2 centimeters represent 10 students. So I put the line to show them to say it's the same number. So first we'll plot 10.5. We're plotting now 10.5 to, I think it was 10.5 to 3. So frequency of 3. Oh, let me put it marks. Always write it marks on the X, and on the Y, you make sure to tell them what we have on the Y is the students. So we'll label our X and Y axis. All right, so 10 to 3, you just go 10.5, 3. 3 would be somewhere here. All right, then you go 20.5 to 11. 20.5 to 11. Somewhere here. Mine is not so accurate, but that's okay. Then 30.5 to 23. Little over the middle, this is 20. 30.5 to 23, little over the middle. Then we have 37 and 47. So 37, 40.5 to 37. Then 50.5 to 47.
That's not 37.
Very good, sharp. That's about 33, right?
Yes, sir.
All right, so 40.5 to 37. This is 33, so 37 somewhere up here. Or that is not 40.5. You need to be closer to this line. 50.5 to, wait, 37? Yeah, that's 37. 50.5 to then 47. 47 is closer to 50, somewhere up here. And then we have 53, and then we have 58. 53, so 60.5 to 53. This is 50, 55 here, so 53 here. And then 58, and then 60. Finally, we get our 60 right on the line. All right, so in this case now, all you do is connect the points. You start from the origin, always start from the origin. Now this point shouldn't be there, so I'm gonna hide it. This point shouldn't be there. That's just the scale point, so it looks something like this. All right, keeps on giving me an angle, so I start from here. You would make it a lot more smoother through all the points. All right, so you just draw a smooth curve passing through all the points. All right, and that would be your cumulative frequency. All right. They say it have an ogive shape. It have an ogive shape. All right, that's how we call it, an ogive shape. All right, and that's our cumulative frequency.
Wait, sir, why does the time wave computer say 4?
Oh, ignore it. I put it to be 3 hours behind. All right, I put it to be 3 hours. I like it like that, so don't worry about that. All right, it's 3 hours behind time, so that's telling me that it's 11 minutes after 7. All right, I keep it 3 hours behind, and my other laptop I keep it 6 hours behind. All right, it just keeps me focused in the sense that I want to eventually live in England, and I just keep it in a time way that on the other laptop, it's closer to England. This time is closer to a country in the subcontinent, but not getting into the logistics of it. All right, but any little cue that you can use to motivate you, always do that. All right. Yeah, so now it's your question, so you can share your screen now. Let me look through which one of the questions I'm gonna ask you to do. So go back to the document. And let me see which cumulative frequency.
Hold on.
All right, no problem.
All right.
All right, now let me see. Not that one because the table already complete. I don't want you to do one where the table is complete. All right, let me see this one. No, not this one. It's not that's not cumulative. Mid intervals. Let me see what they're asking about mid intervals. Go down for me, go down. They say B, calculate. All right, frequency polygon. That's something that we need to do next. All right, so skip, not frequency polygon. Yes, this one is yours. All right, so for frequency polygon, you don't need to write down. For cumulative frequency, you don't need a lower class boundary. Just write down the upper. All right, I love that you break the x-axis. Very good. We're not starting from 0. Three, 23. Yeah, that would be about 23. That's good. 22. 23. Yeah, that's about right. Where's the 89? I don't see the 89.
89.
Didn't you have an 89? You had
Good.
23, 46.
Next one is 79.
Oh, 79. 79. Wait, so something is off here. Let me add up all of these and if I get, do I get 100? 23, 46, 68, 79. Adding up all the frequency, 23, 46, 68, 79. The total should be 79, right?
Yeah.
All right, so what I want you to do then, since something is off, I want you to add another column and just say 46 to 50 and put 21. Just say it be 100. And then you can change the last 2 points then, last 2 points.
Hold on, sir.
All right.
All right, sorry, sir. I was talking to my father.
All right, no problem. All right, so you can put the last point now and put the graph. You're right, stop it at 20. You're right, you didn't have to erase, stop it at 20 because notice that we didn't start from 0, start from 20. Nobody got that low. Stop it at 20, good. All right, yeah, nice. All right, so now look at the question and see what they're gonna always ask you some question using a graph.
It says determine the median score.
All right, so determine the median score. How you determine the median score?
It says using the curve.
Yeah,
So
yeah.
I'll just estimate and just extrapolate the.
All right, so what you do is you look, remember the position of the median is a half the n plus 1 term. In this case, what we do is since the total number of students is 100, what we say is the median would be the 50th.
Oh, yes, sir.
When you list out the 50th student score, you go across from 50, go down and see the corresponding exam score to 50. Yep,
So it's about 36.
about 36. Very good. So the median score is 36 marks. All right, so what if I'd ask you to find the interquartile range? What if they had asked for that? How do you find the interquartile range?
I would use 75 and 25 and then subtract.
Very good, very good. All right. So go ahead and do that for me. Yeah, let's call it 45. Yeah. All right, 14. So 14 marks. Very good. Now, they ask a very important question afterwards, Jamie. So look at it. They ask, what is the probability that a student chosen at random has a score greater than 40? How do you do that?
So it's about 68 or
68, yes,
69.
so 68 or 69, yeah. So many students then, what's the probability that a student's score is greater than 40? All right, so 31%. Very good. Very good, Jamie. Very good. All right, and that's it for cumulative frequency. Now, notice I didn't put anything with line graph in the notes. I know line graph shows trends, but there's no way they're really going to give any line graph question. I've never seen they give line graph. They give it in the paper one, but uh, line graph, it's simple. It's just trends over time, but you don't need to worry about it. However, what I did do here is sometimes you might get like some 1 mark question. They might ask you like, what's the advantage of using the bar chart instead of the line graph, or using a pie chart instead of the whatever the case may be, the histogram. Now, this is where I put in the advantages of each. All right, so Jamie, you can feel free whenever to read through what's the advantage. All right, because you know, whether it is continuous or discontinuous data, or if you want to show periods over time, you use the line graph. Whether you want to look at the relation or comparison of a whole, the best one is pie chart. So you can just read through and, just refresh your memory of the advantage and the disadvantage of each. So whether it's bar, line, pie, histogram, they like to ask that. Don't worry about the scatter plot as yet. Scatter plot is to show the relationship between two variables. And we're going to go deep into scatter plot when we do linear regression. All right, we're working out a lot of wonderful stuff. All right, in scatter plot. All right, so in linear regression, we're going to do a lot of stuff that will be week after next week, because next week we're going to be looking at distributions. All right.
Also,
All right, so in regards to the SBA now, let's see which part we can put in to correlate to what we are doing. All right, so since we did by par, we did bar, line, pi, histogram, let's look back at our numbers that we have. Let's see which one we can fit in, because we want to make our SBA as decorative as possible. All right, I want it to be very informative. All right, so let's see how else we can present our data. Now, it would have been ideal if some persons had ratio 0 point something. It's because everything is greater than 1. That's the real issue. It's going to be difficult now to do with that. There's nothing less than 1, so we don't want to focus on a bar. The bar is
the
out.
point of the SBA was kind of to disprove that it was a one-to-one.
Oh, it's disproved. We're not proving it's 1-to-1.
Yeah.
Okay. My apologies. Very good then. So we can have that. We're disproving. All right. So you read, and they pretty much said that it's a 1-to-1 ratio, right? Roughly. and we're
And
disproving
then
the statement.
you
All
said
right, very good. And that means that anyone can apply now. We can actually use. So we have several data to disprove. I have several data to disprove. So which one do you want to include? I would say go with two. I would say only two.
it's a histogram.
All right, so you want to do the histogram and
Could I use a cumulative frequency?
yes, you can use cumulative frequency. No, I wouldn't want you to go with the histogram, and here's why. We generally want to use histogram when it's continuous data, but persons aren't continuous.
Yes.
So I'd more want you to use the bar chart, all right? So don't necessarily use the histogram. The histogram is more for continuous data, all right? So we'd use the bar, and you can use the cumulative frequency. Now, with the bar, of course, now you're gonna have to put, you can show the different groups right here. So maybe you can put it in a range. So you can use the bar with a range to show maybe from 1 point, maybe you don't want to put so many bars. Maybe you put from 1.00 to 1.03. That would be all of these person here. Then you show the frequency to show majority there, majority here, majority. Only 3 right here. All right. So we can do a bar chart right there to present the data. All right. And still include like a column now, which is from 0.98 to 1.00. You show that, or 0.97 to 0.99, you show that there's none. Right. Just to disprove the statement, it's none.
Yeah.
All right. So that's for the bar. For the cumulative frequency now, let me see, frequency. We don't want to plot ratios, all right? We always want to use the actual datas here. All right, I wouldn't use a cumulative frequency. All right, I wouldn't use a cumulative frequency. All right, because pretty much what we need to plot then on the cumulative frequency is frequency on our y-axis. We have 30 data points, but then on your x-axis, if you're plotting the ratios, it won't be helpful. All right. So this is more, just do the bar chart for now, because these two datas, because we're going to be doing it, showing the correlation between these two datas, it's really going to boil down to the scatter plot to show everything a lot better. This is where the scatter plot is able to compare the two. All right. We want to look at how these two are correlated. So the scatter plot is going to be best. Cumulative frequency won't be a good idea. All right, so just do the bar chart for this week. So I guess that's an easy week. As you can see, indicate the relationship between two variables. This is the one we're going to do scatter plot week after next week. All right,
All right.
so don't worry about it. Next week, what we're going to be doing is distributions. So we can't use distribution in our SBA here. So next week is going to be like pretty much a easy back week in terms of the SBA. Next week, we're going to do distributions, which is binomial distribution and normal distribution. And also I'm going to put in the notes for the identify the shape distribution, symmetric, positively skewed, negatively skewed. So 2.3, going to include that. We do 3.1, the 3.2, the 3.3, the 3.4. We do 3.5, we do 3.6. All right, as you can see right here, this is where we're going. We're going to, all right, we're going to distributions. All right, don't worry, I'm skipping probability, yes, a little bit. We're going to distributions first. We're going to calculating probabilities for discrete probability distribution table. All right, and we'll be looking at normal and binomial. Once we do those, we're going to come back to probability, calculating regular probability. All right. And after we calculate regular probability the following week, then the last week we're going to be doing the last 2 weeks in February, we're going to be doing our linear regression. All right. We're going to be talking about when R value is greater than 0.7, it's a strong correlation, moderate correlation, weak correlation. So we'll be able to look at the correlation between our X and Y values that we have in terms of our SBA here. So the last 2 weeks is when we're going to be really putting in all of this work for our SBA, and then we can start prettying it up for the final submission, right?
All
right, so yeah, so pretty much I'm just gonna send you more questions then to practice, and you also have these questions to practice in the meantime. All right, remember to keep on using what we've been doing before, like mean, mode, median, standard deviation. Keep on practicing question with those. You don't want them to leave you. All right.
Sir.
All right. All right. So take care, Jamie. Enjoy the rest of your
Yes,
night.
sir.
All right.